Yeah, 1:30 is good. No, but leave the door open. Was the notebook stuff. So let me show you what I did for the notebook stuff. Why do I have a warning here on all systems? Possible feedback. Echo cancel. Why wasn't there echo cancel? Anyway, okay, let's see something here for a second. So, oh, wrong project. Hold on.
Let's move this a little closer.
Just make sure we still got some focus Dude, I had
There we
worked
go.
out this window. Oh, weird.
Okay.
Let me just fix that here. Like everything changed somehow. All right. Fine. What? There's too many places to mute. Mute. So,
There it is. We're good now.
dude, that was weird, man. I unmuted the mic, but now Ecamm had a mute option there. So, do I have to repeat myself again now with everything I just said real quick?
Yeah.
Okay, real quick. If you download latest example 14, you'll see a README. In the README, we added something new to the make install and to the make Python install that lets you run a Jupyter notebook from the terminal using the Go NB kernel. But I think the cool part is that thanks to this plugin, which I didn't even talk about, thanks to the Jupyter Notebook plugin, if you do it, it will let you essentially select the Go NB as your kernel, and you can run Go code in a Jupyter Notebook. So that's pretty cool, man, isn't it?
Yeah,
All
that
right,
is neat.
so that's what we basically came to the conclusion with on Tuesday. Now, I thought I had an Excali draw in here.
I thought there was.
I thought there was two. I don't know why I don't see an Excali draw in here. Let me,
You definitely did have one. I remember that with the
I know I did.
MCP or the tool calling. It was going over that.
I know, so it's not under, that's weird, bro. Maybe we got rid of it. Maybe Florin's on right now. Did we get rid of the Excali draw? Or do I do it at, maybe I did it at an example level. I may have done it at an example level. What did we do it for again? Yeah,
there is
look,
one.
step one,
Yep.
Excali draw. Okay. So, I shouldn't really do that maybe I should do the following for the project here. I'll move it to example 11. So it's on the outside. And now for example 13, I'll add a new one. Okay, let's do that. So let me tell you what I want to do. We now know how to run. I have to go through these steps. So we're going to walk through these steps, or at least step 3 today. We now know how to execute Llama CPP calls to do inference like in a chat. We'll walk through that code today.
Okay.
We know how, okay, so let me do it this way. This is what I'm thinking. Think of this as our Go binary. This is something that I want to be able to deploy, right? Maybe I can deploy this in Cloud Run, anywhere. So I want everything sort of self-contained in this binary. So when it executes, it has everything it needs. Now, here's the idea. I have the Go notebook, okay? We have the chunks.
Yeah.
We want to create embeddings. But what I want to do is have an embedded vector database inside the binary.
Okay.
So imagine that we had, and there's only like 300 things. So you can embed everything on startup too, right? It wouldn't be so we can keep it in memory. So imagine that we have, thanks to DuckDB, all right? So imagine we have a DuckDB in memory vector database with all of the notebook chunks. Why is that on the side, dude? See if I can move this. Okay, so this is what I want embedded into the single binary. So step 4 is some code I wrote. We'll go through that as well. That is a hack program on how to use DuckDB to create a vector database. It doesn't have the notebook chunks in there, but we'll do that in like 5, right? This is all about 5. I want to have in here, I want to embed. Now, ideally then we might need 2 models to do this, which gets a little crazy. So maybe at the end of the day, we need to write the vector DB to a file and bring it in. I don't know. Yeah, we need a model, but assuming we can do the embedding, I think Ron has an example, but let's just say we're going really crazy here, right? I want to have my inference model, which I can't remember which one we're using there. Who cares? This binary might be 200 gig when I'm done, but I don't care, right? That's why they have networks. We have an embedding model. Come on, Bill. Embedding model. And we have the Llama CPP sort of all embedded in here.
When you say inference model, what is like a...
Like when you do chat.
Oh,
That's
okay.
right? It's doing inference, right? So in the case of what I'm doing with what you see on step 4, step 3, when we get to it, we'll be using the Quen 2.5b instruction.
Okay, so that's an inference.
Right, which is already downloaded here, and I don't know how big it is, like 3 gig. So, but imagine all this embedded, right? And we're going to need an embedding model, and I think Ron has an example for that. So we have to figure that out, right? So imagine that we're going to have an inference model, an embedding model. We're going to have Llama CPP embedded in here as well with Go support. So this is going to give us our model support, right? We're going to have all this. Then what we're going to do on startup is take all of the book chunks that we have. Okay, these book chunks right here. We already have embeddings, but say we take the book chunks and we embed them in an in-memory vector database. So for now, what that would mean maybe that we have to do those 300 chunks every time, but we know embeddings are super fast.
Yeah,
so
quick.
Who really cares, right? So now you have this embedded in the Go binary. We have this embedded in the Go binary. And then what we do is we add our little sort of chat completions endpoint here using HTTP, right? We have all that code thanks to the work we've done at Prediction Guard. So we sort of implement this chat completions endpoint. And what we're essentially doing now is deploying a binary that has this endpoint that then can basically do RAG.
Okay.
Right?
Yeah.
In fact, if I were going to add another little sort of component to this, this is the, come on, Bill. This is our Go binary. This is our chat completions endpoint. All right. add another box here, which would be some sort of our RAG engine. And the RAG engine would take the question, it would get it right, it would embed it, get a couple of chunks out of here, and then go and do the inference call or llama CPP here, and then sort of send the response back down. And so from a ops perspective, from a deployment perspective, you don't have to install MongoDB Atlas somewhere. You don't have to now install an embedding model and an inference model. I don't need
because
Kubernetes.
it's all just in the binary.
It's just one binary, bro. Even if this thing's 100 gig, right?
It's just one thing. That's
Like,
it.
I know Florin is thinking like this would be a beautiful thing because all I have to do is deploy this binary and run it, and it's got everything contained, but just for the notebook. So imagine then we've got this for the Go notebook, and then the video stuff. We swap this out. These chunks basically get swapped out because the chunks actually are going to be embedded too. Sort of, let me cut this here. The notebook chunks would be embedded into the binary as well, right? We're going to create this vector database, let's say on the fly.
Okay.
Just to make it, I don't know why you're doing that, but just to make it easier, we'll create this on the fly, but the notebook chunks, but we can use the same exact code and just replace the embedding of the notebook chunks with the video chunks.
Yeah.
And now you've got a binary that you're deploying that can do a specific sort of RAG with the notebook.
And do you run into any sort of like roadblocks because of the size of the binary? Like if it's 100 gig,
Who cares?
200 gig,
Who cares? We have memory.
It'll just take a little while.
How long do you think it takes to load 100 gig in memory? Dude, you won't even feel that.
Yeah.
Now, if you wanted to be, if you were worried about that, you could take what was embedded in the binary, write it to disk, clear it out of memory, and work that way, right? Like, but at the end of the day, I don't know if you have to even do that.
Okay.
I don't know. It may not even be 100 gig. That one model was 3 gig.
I don't think it'll.
Maybe the other one is 3 gig. Let's say it's a 10 gig binary. That's nothing, bro.
Yeah. No.
But imagine you did this all self sort of contained, and now you can just sort of deploy this and run it. That gets, to me, it gets super interesting.
It's like a single sort of just run one thing. That's it.
That's it. It's all self-contained. It's not 1, 2, 3.
Yeah.
And then this whole Go binary 4, and then running these 5. Like, think, because when you think about the prediction guard system, which has to be more generalized, right? We've got to deploy these things all over, right? We've got to have a platform that deploys these things, even if you're going to run on a small cluster. But if we're saying to ourselves that this is the only data we care about, this is the data that we want to interact with, right? Then think about this almost as this is a microservice that is tailored specifically to the notebook. We have one that's tailored specifically to video processing.
Okay, I see.
And we can scale that this way. Scale it by, now obviously this binary wants to run on GPU and all that stuff, right? But that's a Florin ops problem. But this, to me, because of the work that Ron Evans did with the Zima, right? This now to me is an interesting way to sort of go after solving these sorts of problems. I don't know.
Okay.
I'd love to, Florin, if you're still listening, man, like chime in. Because Florin is the ops guy. He might think I'm crazy here, but ignorance is bliss. So, so let's do so this is what I want to build. I don't know how many shows it's going to take, but ideally this is what I want to build. So basically when I do go run, here's something else that I thought about. We get this to work with a simple terminal UI. But dude, right? So we get this to work and we just extend, actually it's not even a terminal UI, it's curl, okay?
Okay.
So we can use curl outside of this. All right. So we use a curl, let's just say outside of this to hit the endpoint. That's how we can test it.
Okay.
But thanks to your cursor
Yep.
or Lovable, we could build a chat interface, a browser.
Okay.
Now think about this, a browser chat interface,
Yep.
fully functional, right? And have the Go binary serve that up too. We're doing that already on ardanlabs.ai.
We do the same thing. Yeah, exactly.
So now the binary also has embedded with it the app
Yeah, that would.
that is, again, very specific for the notebook. And this code is reusable because it's just like all that's doing is essentially hitting this endpoint, which is all it has to do, right?
Exactly.
So now you've got all of this. The only thing that changes with every binary
Data.
is the chunks.
Yeah.
That's it. And now you can have and now this is good for the cloud run because just like we do, you have the one. This is what I want to build, bro.
That would be sick.
I mean, and when we get this far, I get Ed involved and we just run it on cloud run just to prove that maybe I'll need Florin or something, but we prove that we can then put this inside of a container, right?
Yep.
Build, which is simple because you're just building the Go binary anyway, and then deploy this somewhere and you're done. You got everything you need.
So it's basically like a starter kit, like a RAG chat starter kit or all in one.
It's all in one binary, dude.
Yeah, all in one
All in
solution.
one, we're done. It is all you have to deploy because you build it all and you embed all these things. Like this is an in-memory database, so whatever. I'll show you that. These models will have to embed and play with the Llama CPP. So this is what I've got. We'll go through the code I have. Step 3 is basically Llama CPP doing inference against the Quen model.
Okay.
Step 4, it's not using the notebook chunks, but maybe we'll update it to use the notebook chunks. But I have a basic working hack program that shows DuckDB as a vector database. So maybe today we'll bring in the notebook chunks for that. Who cares? It's not going to be 200 gig, but who cares, man? Florin, come on now. See, Florin has no right to scream at me because he's trying to do air gap installs where everything is in basically one file / sort of binary. And you're gonna have something fairly large, but I bet you that when we're done, this is like 10 gig, man.
I don't think it would be that big.
Flying, you'd be okay if this was only like 10 gig, 15 gig. You wouldn't even think about it. The network would laugh, man. Would laugh at it. So yeah, I can torrent that. So I want to build this. So let's quickly go. We can quickly sort of go over this code here, inference Llama CPP. I need to find an embedding example, which I think Ron has. So that will be easy. And then I want to work on this code where we're using the notebook chunks and have a program where we can at least pull the right chunk out for a question, right? That's like sort of step 4, how to do that. Once we have this, and then we might need a step 5 for the embedding model, or we'll add it back to step 3, right? I don't know yet. But once we have the embedding model and we have this coded, we know how to do the rest of it, bro. We know how to do the rest of it. Like we've knocked the rest of those walls down, right? Everything else is just like busy work at this point.
This is interesting.
This is crazy.
Yeah. This is interesting. Right? I would love to see a work where you just go, boop, one binary.
I'm gonna have Florin deploy this binary, single binary, and then you're gonna watch it work with the browser app. Okay, and then Florin's gonna go, yeah, just made my ops life really good.
Interesting.
All right. So let's take a look at two pieces of code then, and then we'll figure out how to extend it. Yeah, of course, Florin wants to do this. Of course, it made his life good. You know, where I got some of the ideas from Florin is from Adam when he started embedding models in the Go binaries to sort of deploy them. I sort of clicked some ideas on this. All right, let's take a look at step 3 real quick. Ron Evans has done some really cool things here. So he's already created code that can reach out to the internets and download the C libraries that we need for the architecture that we're working on. So if it's not there already, it will do that. And this is something that's good too from a production perspective because it can sort of write that out. Now, I told Ron, I'm not happy that you've sort of done things with an OS environment variable instead of a parameter, right? Like I told him, we should be passing this value in because you're making me use your variable. So I find that to be troublesome from an API perspective. But at this point, whatever. What are we talking about? Step 3. So this is basically where the C libraries are going to go. You can see I put them under Zarf there. And then we have to set this path so when we execute this code, it knows where to find it. Right? So these are the only two things we sort of need set, exported before we run. And then you can see the model we're going to be using, which I've got sort of down here. They're too big to keep in the repo. So this is beautiful code. And Ron's done all this weird stuff with flags. They don't really need it for what we're going to do, but I didn't want to completely rip apart his examples. So I have cleaned them up a little bit. He did have some extra stuff there. So essentially, handle those flags, whatever their flags are, like what model we're going to use. Install Llama if it's not already installed. And now this all comes from the work that Ron Evans has done to map Llama CPP as a Go API without us needing to do any CGO. You don't see any CGO anywhere here.
Yeah.
So we're going to load the library path. All right, so that's where all the APIs are for the architecture that we're running on. There's some sort of call to init, and then a way of freeing that. If we're in verbose mode, like we pass a -v on the command line, or not verbose, I guess, we set log silent. Then there's an API for loading the model with some parameters that we can set. Defer freeing that model. Then there are context parameters like your context window, some sort of batch size. I don't know what
I haven't seen batch size.
Yeah, I don't know what the batch size means just yet. But we know what the context window sort of looks like. Then we can load the model. We got the model from here. So init from model with any of those context parameters, we can free that as well.
Makes sense.
Then there's this concept of a vocabulary. I don't really know what that means, but you pass in the model and you get back a vocabulary. And then you can add things to this sampler. So top K, top P, min P, temperature. I don't know what the default seed is. But you add this stuff to something called a sampler. My guess is we'll have to create a sampler on the fly for every request or something because top K and all that's going to change.
Oh, yeah,
right?
That makes sense.
Okay. Then there's a concept of a chat template that you can pass in. But in this particular case, I'm not passing in a template. So this template, why do we see template again? Oh, template's coming from the flag side. This is like, that's why I'm kind of bumming me out a little bit with the flags because it hides some things here.
There it is. Yeah.
So if there, as the default, there is no template. It's going to be an empty string.
Got it. What would be like a template?
I'm assuming that it might be like the model templates that have that model less than pounds.
Oh,
Like it might
okay.
be that. It might
Okay.
be that. Might be that. So if there um, is no template, then he sets this sort of Llama model chat template for the model. So my guess is Llama CPP has already maybe templates that it can match or something.
Got it.
If it still couldn't match it, then it's setting it to this thing called chat ML. Don't know enough about that. We're going to have Ron on next week to give us some more information on these things.
Oh, cool.
Then we create a slice of these chat messages. We add a system prompt if we have one. We understand all that. And then if the prompt, right, you can pass in an initial prompt.
Yeah.
If that was passed in on the command line, then we'll add that prompt to the messages.
Okay, and that's from the okay, because there's a system prompt and then a user prompt. Okay. Yep.
Then there's this function called chat, which we're going to be using anyway. But it looks like he does some sort of chat with another function called, well, so we're not going to do any of that, right?
Yeah.
Okay. Then we get into this sort of loop.
Yeah.
Where we create a reader for standard in that lets us read the question. I like what Thorsten did for some of that. But again, this could be whatever the curl call eventually comes in. But whatever we type in, we append it to the messages, right?
Mm-hmm.
Makes sense.
Yep.
And then he has a chat function, which takes a call to the chat template. So here's the chat template. It essentially, what are we passing in for? Whatever the template was, which is going to be whatever this returned or that. It might be fun to display that on the screen and see what's there. And so if we're adding this, what are we passing here? False or true?
True.
True. What are we passing here? True.
True.
So I don't understand that just yet. But he is passing whether this is first or not. So at least on the chat template side, if we're going to add it, I guess that goes to this API call here, add assistant prompt. I don't know what that necessarily means. I mean, I know what an assistant, like the assistant is the model.
Yeah.
But so he creates a buffer with a length of 1024. And then he says, apply this template with these messages, add the system prompt and send it. I'm guessing it's send it to the buffer. And then I guess that's always going to be less than 1024. We should print some of this out.
Yeah.
And then he basically returns this buffer to the actual length of bytes that we added to it. So he's pre-allocating it.
Okay.
But 1024 is, I don't know if that's large enough. Maybe that's the context window. That's probably a context window size that he's using.
Okay.
I wonder.
I thought we had did that in some other
He's
code.
using 4096 here. But I don't know. We'll print some of this out just so we can look at it a little bit more. And then what happens here is what he's passing for text is the chat template. So he does this thing called tokenize. So given a vocabulary and the text and some tokens, which right now is nil, add special. We pass true for the first time, not true anything after that.
Okay.
Parse special true. Then he creates another slice of a given length based on what tokenize says. And then he calls tokenize again, but this time, instead of saying nil, he gives it the buffer. So I guess what he's doing is he's saying, I need to know how large of a buffer I need Now, I feel like this is very inefficient.
So he's doing the call to tokenize first, and then he's
To get a
putting.
count, so he knows how big of a
Yeah.
buffer is, and then he's
Okay.
putting it in.
Yeah.
We could have some efficiency there on the buffer, but if the tokenized call is, I don't know if the tokenized call will not go past the buffer.
Hmm.
So there could be some efficiencies here that we can do. Then he does this thing, returns a batch for a single sequence of tokens. He gets some sort of batch. I don't know if we even go through this code, but he's asking, does the model have an encoder? Doing some weird stuff here.
No.
But if it does, it looks like he's calling this again. And then we basically take that batch and decode it. There's some vocabulary. We put that in a buffer, and we basically can print what this comes back.
Hmm.
And then you kind of get the next batch. And so you get sort of these words or something at a time. We can put a bunch of sort of print statements in here and get a better sense of sort of what we're getting. But I think these batches are going to be tokens that get converted to sort of words at some point, or it could be partial words. We can play with that.
I got it.
This API isn't completely obvious, which is sort of why I asked Ron to come back on the show, because I wanted him to sort of walk us through this. So Ron's going to be on the show on Tuesday. So
Okay.
we've walked through this. This works, right? If I go back to, and we did this yesterday with Jan, or Tuesday with Jan.
Yep.
I come back here and do, oops, wrong one, sorry.
Oh. Loading model.
Man, it's taking a long time. Hello, model. Okay, so I know this code works, but I think it will be fun. Oh, dude, let me have the power. I just realized I'm not plugged in. How much power do you have?
I'm
Oh,
good.
you're
I'm good.
better than that.
Yeah.
So maybe we walk through this code with Ron on Tuesday and get more in depth on how we sort of do. And when I show Ron what we want to do, it gets interesting. Okay. Now, this is what I sort of put together today, which was step 4. And this was the DuckDB stuff. So this is a happy path sort of hack program that will give us an in-memory vector database using DuckDB.
Okay.
I found DuckDB when I wanted to replace LanceDB in the Python project that we were using.
That's where I've heard it from. I was like, man, I've heard DuckDB.
Yeah.
Okay.
So we ended up not doing that. We ended up staying with Python.
Yep.
Because we were told that LanceDB was doing more special things than just the embedding database. And I didn't want to start going down that rabbit hole. But we found this, I found this when we were doing that. So you can see here that it has a DSL for SQL, and you can run this as a separate service too, just like LanceDB, right? But I think the cool thing for me was having the vector database sort of in there.
Okay.
So if you've never seen DuckDB, it's super interesting, right?
Nice website.
Yeah, website's kind of cool. And they have support for all this stuff. You just got to make sure you're using V2 on the Go side.
Okay.
But basically, you don't have to do much more than just get this thing, and it just sort of works. So let's take a look at this code here, and then maybe what we can do is extend it to work with the book chunks and see if it's actually doing a decent job on the embedding.
Gotcha.
So importing the V2, and I do this DuckDB new connector. Now I can give it a file, like it takes a DSN, right? I can give it a file name if I want, and maybe in the final product, maybe what we can do is just create a DuckDB database and embed that and then read it in. Though I think it's not going to take long to just sort of embed everything
Embed. Yeah.
and then run it, right? Well, we're going to find out. So you can say, hey, this is going to be in memory. I don't have to pass it any other sort of driver. So that's kind of cool, right? At that point now, we can just use the SQL package. So I do an open database using that connector to further close. Now, if you want to do vector search, you have to send this DSL in. In fact, the one thing I was doing to make life easier, and I should do it here, I was sort of separating this just so, so let's do that. Just so it's like, yeah, this is the SQL.
It's better documented.
I think so. So we're gonna, we have to load this. Maybe this comment works better here though, right? So we have to make these two calls to load the vector similarity search extensions, which are there. It's not there by default, but they're available.
Yeah.
So we execute that query, or really those commands. Now, none of this is like rocket science for us anymore because we've done this stuff. So we create a table. Yep. It has some primary key. It has a name. And in this particular case, I'm using a 3 value embedding vector, right? We're going to change this, obviously. But this is what we've got. Okay, so we'll execute that. Then, as a test, right, we'll insert into items this, right?
Some just
and then these values.
Yep.
Okay. And I can do that. And I try to make the values a little off, but this is why I really want to play with the book.
Gotcha.
So I'll execute that. Then we can do a create index. So I don't know if we can do this before or after, but right now I'm doing it after. Now we create an index on the embedding field using this with a metric of cosine. So this should give us cosine. Now it looks like this is doing similarity search using cosine distance. So I don't know if that's cosine or cosine distance might be similarity. Cosine.
I thought it was the same.
It could be. Maybe we do something like here.
Yeah, exactly.
What does mean, and are there other options for creating an index for vector search? Let's see what it says here.
Thinking.
Hierarchical, navigable, small world, a graph-based algorithm for doing nearest neighbor search that builds multi-layer graphs. Other vector index options, IVF, flat root. I think we want to do the approximate nearest neighbor. I think we want to do the ANN.
Approximate nearest. Okay, trees.
Yeah.
Like
See,
Spotify.
It offers excellent recall speed trade-off, though it uses more memory than. So that's fine, right? And even the comment I got was about a similarity search, which is what we're really looking for. So we'll create this index. We are saying cosine, which is cool. We'll execute that. Then I'm doing sort of two things here. This is just a basic query. So this will just return all the embeddings that we have.
Yep.
All right. You can see this too. We can leverage the convenience package I wrote for the service class. We can make this easier to do. But anyway, do that. And then here's a similarity search. So select, right? You can even sort of make this look better. Select from order by. It's kind of how we would write SQL back in the day, more than what you're seeing here.
Got it. Not necessarily inline, but
I just I've been doing SQL since the early 90s. So just kind of, even this, like, that's fine, right? Because it's an index. Like maybe we put all that on one line. But if I'm going to read SQL, capital letters, sort of do it sort of like this, it's just easier to read. So you could see here, even this, if we wanted to go a little crazy, we do something like that to make it even more readable, right?
Yeah.
So,
Betting. Okay.
I mean, it all parses out anyway. So, and you can see that these question marks mean parameters. So we can, this is how we would do the similarity search. But what's happening here is we're saying select these fields, do a cosine similarity from items. Now, when I say order by and then limit 3, that's not really, now that I'm reading this code, it's not necessarily doing an index per se, because we're calculating. Let me think about what we're doing here. Oh, this is the query vector, right? So this is the vector we got back for the question.
Okay.
Then what I'm saying is,
do a cosine similarity.
so we're basically comparing the embedding value we have for this row,
okay,
with this.
Mm.
So we're actually, this is actually doing it's checking everything. And then it's coming back and just giving us the top 3. So I don't see how this is using the index at any level, because you essentially have to scan. You have to do a comparison. This code is comparing this with every embedding that we have, and then just returning the top 3, right?
Yeah.
So that feels weird to me. I'm wondering, okay, the code starting on line 108 doesn't seem to be using the vector index to perform the search, right? It's just creating a similarity score for each record in the database.
Okay.
Right?
So it's not necessarily comparing. It's comparing
everybody. Efficient way to use the index. To me, it's not really using the index.
It's just comparing over the whole.
Yeah, we're doing it every single time. Now, we're going to have 300 entries in there. Maybe it's no big deal. But like, we went ahead and created this index.
Oh, yeah. There it is.
But I don't think we're using it.
It did, oh, okay. It replaces it right away. It doesn't like.
I don't know what that did, though.
Cosine distance operator. Approximate nearest neighbor search.
I still don't think this is, because it's not a where, it's an order by. You see, like, I bet you that code doesn't even run. Hold on, let me see. We have to run step 4. I just don't, I feel like, okay, hold on a second. Shouldn't we be using a where clause to hit the index, not the order by? I don't know how an order by helps at all with index, like where clauses are around about indexes.
Yeah, because order's just sorting.
The query optimizer recognizes order by embedding as a k nearest neighbor query and uses the index.
Range queries finds all vectors within a distance.
Okay. How can I see that we are using the index? Use explain. What did it just do?
Said explain. Oh, I put a whole bunch of stuff in there. Put a bunch of prints. And
Okay, so it added a explain here. It did the query twice, didn't it?
yeah.
It says query plan. Let's see. Let's run this. Let's see what happens.
Expected to destination.
Okay.
Scan.
So I'm going to give it that message.
Mm-hmm.
I am getting this error about seeing the query. So something's wrong here because
But it's not expecting.
the scan should get
Oh.
any number of variables.
Oh, yeah. Let's see. Thinking. It made some changes.
Explain key, explain value.
Explain returns 2 columns.
Let's see. Okay. Whoa.
Oh, wow.
That's crazy right there.
Okay.
Okay. Query plan. I didn't write physical plan. They did. Projection. The projection of the fields.
Okay.
Order by ascending.
Similarity.
I don't see. I don't think there's an index being hit.
ID top 3.
See, I still don't think an index is being hit.
I'm
seeing sequential scans, which I would expect because essentially this query, right? This is the query here. Is it's funny that just went to -1, but this because there's no where clause, it has to go through all the, you know what I'm saying?
Changed a lot there. Top 3.
Projection, limit, filter. Yeah, I don't know, bro. I feel like something is off here. The order by don't make any sense to me. And I forgot what this meant. What did the embedding query limit k as nearest neighbor query uses the index where which finds all vectors within a distance threshold rather than the top k. Well, I tell you this.
So it's not really going by similar, it's just going by a distance. And the order by is sorting it. So it brings them.
I would expect to see this index being used, and I'm not. I'm not seeing. Okay. Still not seeing index show up in the explain. I may have to stop using the agent and start digging in ourselves. The data set, the data set is too small. That's smart. Okay, that's fair. So that is very fair. These databases, depending on the size of the table, it wouldn't necessarily
skip the index. Array. Okay, and then now it's going back the other way. It's like going back to how you had it originally. So maybe if we go back to the original code and just have it generate some more data, see what it'll do.
Yeah, we definitely have to.
But did
we can
array
look to see
cosine.
what changed, but
Before it was array.
Yeah, we still. Yeah, we weren't. Oh yeah, it went. It changed the.
I changed it a little bit.
Now use array cosine distance in order by to trigger the index. Okay, let's see if even with a small data set that changed anything. Guess what? At least I'm seeing it
Index.
now.
Okay.
So
and then it goes to.
I still feel like we won't know until we. It's 4 rows. The data set is small.
Yeah.
Okay.
Cosine similarity. Okay, yeah, it was array distance before. Now it's array cosine distance.
Okay. So let's keep this. Okay. Let's keep this for now. And let's assume that, excuse me, we need more data. Okay. But this explain is pretty good, bro, because we get sort of that.
Is it the explain that's giving us the tree, and then this is what's actually printed?
Yeah.
Okay.
But, you know, I don't know how accurate this is, right? I really want to use words and stuff because, okay, so we got a couple problems now. I don't want to fabricate the data here. We need a real embedding to then load up all those books and sort of test this out, right? So,
Okay.
this has to change. We've got to do this. These 2 lines of code, right? So that's the create table. This is inserting the data. That's creating the index, and then
that's the.
Where's the question coming from? Like this is the sort of the question. I don't really need to query all the items in the database, right? But I'm going to comment this out for now. I don't need this. I want to go right to this, right? And this would be the question.
Yep.
Okay. Now, we need to be able to do an embedding. So I wonder, why are you complaining?
Rows.
All right. Let's go to, real quick. Let's go here. Oh, thank you, Ron.
Embeddings example. Nice.
I have to sort of parse out really what we need here. So, one, I have to figure out what model he's using for this example. He's using some GGUF. So we'll figure that out. But let's do the following. I got some code here, right?
Okay.
And what I need to do here load data, and we definitely have to pass that DB. Oh, I turned off tab completion. That's fine.
Mm-hmm.
I hate log fatal here, Ron, but it is what it is. Let's turn that back on real quick. Getting lazy in my old age here. Okay, that's fine. And I'm going to add a new file called load.go. Function load data, takes a SQL DB, returns that. And this is sort of what we have. I just make sure everything else is good. And that's right. Just return the error. And that's right. Okay. So this should just work the same way based on sort of what we've done here. Okay. Now, from a Ron perspective,
Llama load.
let's start stealing some shit here, just hacking on this. Now, I need that for sure. When I go back and I look at step 3, I kind of did all this already, right?
Yeah, the llama load, llama init.
Right? I do all this. Llama load. Let me do the following. Make my life a tiny bit better. All right. I need that. I need a lib path, but the lib path is coming from...
That was from a variable, right?
Yeah, the variable for... library. But I think he was reading that.
I thought that was...
Here.
Yeah, there.
That's this, right? So let's just go back here and just... Again, we're hacking right now, right?
Yep.
Okay. So we have that. Oops. Step 3 main. So we've done that. I don't care about this. Load model from file. So we sort of have that, right?
Yep.
I need the model file. I don't know what model file we're using yet, but let's just say that we're going to hard code that there for now. I don't know what we're going to use yet. Model free, got that. Now he does the parameters, which I also had sort of here. He's got to add some new stuff to it, though.
The context.
Yeah. So he added, let's just steal this for a second.
Oh, pooling type and...
But I'm just going to keep the variable names, right? And the pooling type, yeah, Ron, where did you get pooling type from?
A switch.
Ah. Let's assume that he's, whatever that means. Yeah, I know. Give me a minute. Then he does init from model, which I also do. You know, I'm trying to create consistency in all these examples because he's done them at all different times, I think. And so like he's changed variable names and stuff. And
gotcha. Okay.
I'm trying to like keep everything within some scope of.
Okay.
Then he's got the tokenized stuff,
Which
I also have somewhere. Oh, that was sort of in here.
there it is.
Tokenized stuff. So
vocab count tokens.
Yeah, vocab.
Which vocab was above.
Yeah, I was able to put it above, but the other one was because he's doing one embedding, right? Eventually, we'll have to put all that in there. So we had vocab. He's got vocab. Okay. He does a count on a prompt.
He does that bit of code in the other function.
Yeah, he did that inside this loop, remember?
There.
Right. He's calling prompt nil nil. So if I take this, which is basically these same 3 lines of code, right? Now, I don't have a prompt. My guess is he's going to be in the same place. Prompt to embed might still be an empty string, right? I don't know enough yet. We have to look. Because I normally don't use a prompt for embedding. Okay. Then he does the same thing.
Batch the code.
Now, the prompt might be what you're trying to embed. Okay. So let's try to embed this string. Then he does that. That is my guess. And then he gets the embeddings. This returns the slice of float 42. Now he does something here called
normalizing them,
which I don't understand, but we're going to put it in here. Okay. And we might just have to pull this out for a minute and just create a hack function for a second.
Okay.
I guess nothing fails here. That's fine. I just want to see this run, right? So the big thing is if this works, we sort of have a model to do more stuff with. I just don't know if we have to, like the normalizing of the embeddings or something is interesting to me, but we'll see what all this does. So I don't know what model he's using for the embedding. Now that's my problem. So I need to know how he's running the embedding. Where did I find him? It might be here in the README. Hold on.
Sequence model.
This is not the embedding example. Installation examples using BLM, using small models or whatever. Okay, so he didn't tell me which. It's not telling me which models he's using here. All right, so I guess we can choose any GGUF embedding model that we can find. So this is where, like, I wish I had Florin. Oh, because none of this is easy now. We got to go to sort of
Hugging Face.
Hugging Face, GGUF, small embedding model. I don't know what embedding models we've used before.
I feel like we've used BGE before for something.
You think Olama's got this one, which is interesting.
BGE M3.
A BG. Oh, but look
BGE.
at this. This is kind of interesting.
Embedding a Gemma.
I can also look for a.
I don't think that's a GGUF.
Hugging Face. BGEGGUF. Here. My problem is like where I get lost here is, okay, so Kim Chen has this
Oh, it's converted.
thingamajig, right? But like, I don't know who's the original. Like this feels better, ggml-org. 8-bit, 600 meg. We can try this one.
More details.
Now I got to remember how to get the, I think I click here and I get a link here, copy link address. Hold on. Just so I have it in here. Let's see. Let's try this one. Didn't ask you to do that.
It should be a, oh, okay. So that's how you.
I'm sort of doing it. Yeah.
It's giving you.
Oh,
there's two. Yeah.
So
Download.
I could try to run this. Hold on.
And the quote. Yep. Okay.
So that's 605 meg. Probably can find a smaller one. Then, I mean, it's under a gig, right? I want to embed it. Okay, so we now have the BGE.
M3 GGUF. Or
This one, right? Edit.
Yep.
So that's the model we're going to use. I need the, let's go back here. Sample. We need to set all this. Fine. And to run the hack program now, I'm just going to do this. I know. Let's do that. Just run hack. Okay. So let's see if we get anything back from running step 4. Whoa. Whoa. We got it embedding. That kind of looks normalized. I wonder what this.
I want to know what is. In the square root.
What is he doing here? He's getting back a slice of floats. He goes to each float. He sums the whole thing up. Float. Gets the square root.
64s and then
creates a norm.
32.
And he goes through each one again. And he does V times the norm. What is it if you don't do times the norm?
That was an, yeah.
I don't understand.
And then, like, if we went higher up. Oh, is that? Oh.
That was minus 0.002561, right?
Mm-hmm.
This is the first one we saw. Hold on.
Oh, 32.
Hold on. Maybe just here for a second. That's what we saw when it was normalized. This is what we're seeing when it's not normalized.
Really?
I don't know. Why don't we ask our agent?
Yep.
Okay.
Make similarity comparisons fair and stable by removing vector magnitude and keeping only direction.
That's for normalization.
Yeah, that's what it does.
Okay. So ideally, then we have to write back this v times norm back into each sort of element, really.
Yeah.
I mean, ideally, you have to do this. If I is greater than.
Yeah, if you're using cosine similarity or inner product.
Exactly. There. This should give us the same answer. Yeah. Okay. So guess what we just did?
Made embedding?
We have embeddings.
Yep. Okay.
However, yeah, and we have an embedding for, let's try to embed this string, which really is not prompt, it's the text, right?
Yeah, I think text is a better name for sure.
Okay, so this will, we gotta write this a little bit better though. So we only have to load the model up once. Okay.
Because this is going to have, certain parts of this is going to have to run in a loop, right? To go through sort of every chunk and embed.
So let's do this for a second. All of this code, I can't do the defers, but all this stuff is essentially stable. Okay, type embedding model. Function new embedding model. Return that for a minute. All this code up till this needs to be in here.
Okay.
So the model file can be passed in here. That's fine. I don't want to lose this just yet. Okay. We load, we do the init. Now we will need, I'll just put it here and then I'll move it. I don't know what to call it. Just call it a close.
A close because you can't do the defers?
I need to do an unload, right, to free everything up.
Okay.
So essentially,
it's going to call it, yeah. Okay.
Well, that's fine. And so we do the init. This, by the way, really should have been an error. Okay. We're going to do this, right? We need to keep the model. So we'll have a model, llama model, and then we need to free that.
Yeah.
Okay. Assuming we can just use those. We need a context. And we got to be able to free the context. Probably L context is a better variable. Okay. Then we need a vocabulary. Okay. And then here, we do that. Now, I always hate to have that returned on the nil. So I'd rather do a return address em nil. I think it reads better. So that's all that initialization crap, right?
Yep.
The cool part is this doesn't return errors.
So you can just do it right there. You don't
Just
need
do
to.
it right there. We don't need the extra stuff. Now, that gives us a new embedding model. And then we just, this is our first method, which is our shutdown, right?
Yep.
And then we just gonna have a embedding model embed. That's fine.
Oh, it's freaking out there.
Yeah, I know. I don't know how to use it. All that seems reasonable. And I would say all this code. So that goes into here. Let's see.
And it's getting text. Yeah.
Nice.
Boom.
Okay. Don't need hack anymore. So we now have the ability to get an embedding, right?
Yep.
We need to test that out a little bit. So if I come into main, I liked what it gave me. I just didn't know how to accept it. So let's create a new embedding model.
There it goes.
Okay. So that gets us a new embedding model, right? All this happens. Now we've got load data. Load data should take a embedding model, right?
Which I think it's, yeah, there it is.
Okay. So now load data takes an embedding model. Now, what would be nice is if we just hacked for a second here. Okay. What if we did? Stop. Sometimes I just want to turn it off. Let's pretend that we've got some strings that we want to embed, something large where it's reasonable, but on different contexts, right?
Okay.
So I wonder if I can do this. Hey, give me 5 sentences about completely different topics to add to the data slice. I was just going to do it myself. I'm like, what am I doing?
Yeah. No, that's perfect AI use right there. There you go. Single teaspoon of honey, human brain.
Okay, fine.
Didn't want to do it completely for you.
Whatever. It will fix it for me now anyway. Okay. This is good.
Pacific Ocean.
So let's iterate over this, create an embedding for every one of these, and then we can try a question and see if we like what we get, right?
It's actually some interesting facts. Human brain generates 23 watts of power.
Florin's brain It's like 100 watts because he's just it's Florinus right there. My brain is like at 5 watts, man. You know, if somebody goes to the Great Wall of China right now and adds a little bit more to it, we can change that
Yeah,
2,000 years to
just put another brick.
just put another brick. All right, let's do the following first. That's essentially what we want to do, right? I want to put this in here too. So let's do something like this. Okay. Insert. Actually, we can do this here. Insert into values, right?
Mm-hmm.
This is a really bad way of doing it, but that's kind of what we need.
But we don't want those.
Let's see what we get. And then we want to execute that and put that data in. I need I. And what we can also do is print SQL just to see what we're getting, right?
Okay.
So this would load that data in, let's just say. And once we load the data in, and we index it, now it's kind of interesting to see this. So let's add this back. And then the query vector should be, we need another question here. So this question is going to be,
fun fact about
tell me something about the,
there you go.
the Great Wall of China.
Perfect.
Now, we're going to need this call, right?
Embed. Okay. Yeah, because we have to embed the question.
So that's the query. That's that. Now we have a vector. And we need to, oh, shoot. How large is the vector, dude?
Oh.
We didn't ask. We need to know how large this embedding vector is. So it's all going to blow up, but length vec. So it's all going to blow up because I don't know what that is. But you know what we can do? We can do this real quick. Hold on. Just do this for now.
Just to get that, yeah.
The first time we run it, we'll just do this. That way we can see what the length is. But assuming that we now know the length, whatever that length is, okay. We need this in that bracket sort of thingamajig. Though I wonder if we can just pass a query vector. Yeah, vec.
Vec.
I wonder if we can just pass the query vector in.
Query.
All right, let's just run it just to get the number first. 1024.
1024.
Okay. So,
which maybe explains why he did that buffer of 1024.
Yeah, because it's only going to be at 1024. Okay. So we know we're going to get back 1024. I'm hard coding this right now, but so we're going to have a 1024 embedding. We're going to do a query. We're going to call embed. We're going to see if we can pass the raw float
Okay.
here. Because that would be really good if we could. Do for here. 1024, 1024. I don't know what happens. Let's run it.
Okay.
I don't expect it to work, but if I do the following, hold on. So get rid of all that extra noise here. Okay, so let's fix the insert because that probably failed.
It said there was a syntax error.
Yeah, I'm wondering. You see, when we do the SQL insert, oh, we printed the SQL, didn't we? That's what we're seeing here.
Hmm.
I mean, that's what it wanted. What was the original? Shit, I got rid of the original. Oh, maybe not. One apple, that, right, numbers. I mean, I've kind of gave it
Yeah.
that, didn't I?
Yep. 84. Yeah. It looks right.
Maybe the comma. Oh, we were trying to build an entire, and I missed the semicolon. Okay, I think I know what I did wrong. I can't execute this just yet. If I'm going to do that, I can, okay, I know what I did wrong. Let's just do it this way. Do one insert at a time instead of like a bulk.
Okay.
Right. Like that's the way it should be because I put the execute in the middle of it.
Oh, okay.
You know?
I see.
Okay. I'm not getting an error. We're not logging the error. So let's go back to load data.
Error loading data. We're just getting an error 1.
I know that's weird because if that's failing.
Oh, we did get it, but then when you added that to whatever it was in the make file, it went away.
No, but this is my own error, right? Like this got rid of all of the oh, because we're writing errors to standard. Let's see, standard error. We're using log.fatal.
Yeah.
All right. Log dot, how do I change the default set output? Yeah, okay. Okay.
Parser error, syntax.
Oh, the extra Earth's total surface.
Oh, because of the
of course, right? Like, why would that
yeah.
be anything? So the other option then is I wonder, well, assuming we keep this, we just have to do the following. That will solve it. Okay. Well, ideally we should be doing that here.
Because the data could have, well, the data's going to.
Yeah, I don't want to change the data, so.
Exactly.
That should be
Okay.
fine.
Oh, that's tricky.
Yeah, but that's fine. That should fix that problem.
It's taking a little longer. We're near 0 to line one. Oh, wait.
Okay, it's still the first one. We solved this problem.
Well, now it's coming in with 2.
No, that's fine.
Okay.
But the syntax error is near. Oh, there's no commas.
Should there be? Yeah. Okay.
So
Why wouldn't there be?
because I'm just printing out the Go's formatter doesn't put commas, it's putting spaces in between, right? Now, what would have been nice though if this worked, right? I say it's floating point.
No.
But it's not liking that. And there may be, because when we define this, hold on a second, we define it as being a float. But when we put this together, it wants it as a comma delimited.
Yeah.
I mean, the hard brackets and all that, right? So, okay, so then vec dot sprint. It's really a join I need to do. Let me see something here. I need to do a strings dot join where that's kind of what I need to do. I don't need the extra space though. And I'm sure there's better ways to do it as we learn, but
yeah.
Oh, split.
It does split this.
I want to split, but this fumpt is all I sort of need.
But you're.
I'm basically saying take this, which is going to look like bracket, number, space, number.
Yeah.
Okay. And what I'm saying is here's the string.
But it.
Oh, not split, not split. I want. Why am I using split? Why is split come in here? Oh, that's what's confusing me. Stop trying to help me. I want to join. So given, oh, I need this as a slice of, fuck. Okay. Join would have given me back a string that's comma delimited. But what I would need then is a slice of string. I have a slice of floating point number. So the other option then is to do another replace, just to hack this, because there's got to be a better way to do it, and we'll ask it. So given...
Replace all the spaces with a comma.
Yeah. It's kind of... Now, there's got to be a better way to do it. I just want to see it work, and then we can sort of optimize the craziness.
Still...
Okay, so that worked. Hold on.
I don't see them, though.
Top 3. I don't...
Oh, because it's giving it to you straight.
So we're going to fix that. When we do the top embeddings, we only want to show... Let's show one number, right? Fine. Oh, the other way around. Yeah, one number. Oh, I didn't do it twice here. Let's see. I'm printing out the embedding.
Top, what was it? Top 3.
Oh, I'm still printing this here. I don't need it anymore. Okay. Why am I still printing the full embedding?
Top three
Top
similar
three
items.
similar item.
Yeah, that one. Top up here.
Yeah, but where am I printing? Oh, similar items too.
Yeah.
Let's just do that right now.
Okay.
What was the question?
Something about the Great Wall of China.
That's all I really care about.
Yeah, something about that. Which did have the highest. Great Wall of China is 6.5.
No, again, the content is small.
Yeah, exactly.
But
it only matched that.
How about we do this instead? How long did it take to build the Great Wall of China?
76 better.
That's better.
So
it's working.
Yeah.
I mean, the other one was like 30%, and these are small sort of things. So it's working.
Nice.
Again, I don't know if we're using our index yet, though. In fact, I don't even see the use of the... I feel like we went backwards on the index, but until we've got a lot more data, that's hard. But so far, this is pretty interesting, right?
Yeah.
Okay, so let's do the following. Let's do the following. We can now start to use the book chunks.
Yeah.
Right?
Because now it's embedding, loading. Yeah, we can.
Right, and I already have the book chunk embeddings file in here.
Yes.
Where it is. Like I
Data.
have it here, right? So I can steal. Let's see what this code does. Okay, good. I have this. Let's go to load for a second. So now, if I do this, I do this. I do this.
And then that's all Mongo.
So
Okay.
when I need this,
Okay. Document.
put that there for now. So oh, no, this is wrong. I don't want those embeddings. We have to create an embedding. So I took the wrong thing. I need the code that creates the book's embedding.
Okay.
So let's fix this again. I need this. Read the chunks.
And then output.
Let's see. Then do that. Steal this for a second. Okay. Now, you want to truncate whatever. Oh,
Okay.
yeah, we don't know what that is yet, do we? Okay, so that's some work we have to do. Assuming that, oh, that's funny. Counter chunk. Why does this work? This variable already exists, and I'm using short variable declaration operator here. That's weird. There we go. Why would that have ever worked?
But
Why is that
the
not a
line?
syntax error?
Is it not the same exact line?
Doesn't matter. The variable already exists. This should not allow me to create a new variable if it already exists. It didn't let me do it here.
So weird.
So weird is right. That I don't understand. Chunk is a local variable. Maybe it's allowing me to override that, but it just feels incredibly wrong. Huh. Well, I don't like it. It's working. So let's fix it. Now, that's interesting, but this is potentially a problem because I don't know how many tokens we end up here. And if we go back to Hugging Face for a second, I think it should tell us.
Embedding context length, embedding length.
I know, but I don't know how many tokens it will. See, this is again when I need Florin. Huh. All right. Well, I don't know what KV count means. General size label. I don't know. Oh, context length here. Okay, 8192. Okay, 8192. So I think we're going to be fine with that. And remember that other code we had that set context anyway? On step 3, we were, right?
Yeah.
We're going to talk to Ron about this one, but
Context.
we're going to take it from the model anyway. I think we're going to be fine. So let's do the following. Let's try to run this now for the book.
8K context is like 3,500 words, someone said.
Yeah, our chunks, some of our chunks might be that big, but that's fine. I'm good. I'm good, at least with this test, I'm good, right?
Yeah.
So now what we're going to do is we're going to read what everybody has access to. This.
Yeah.
Yeah, that's what we're going to read. And that's, now we're going to create embeddings for all of that.
Okay, so you'll be regenerating that file there.
Every time. We'll see how long it takes.
Yeah.
And you can even put a wall clock up. But now the question is going to be, how do you declare a variable in Go, right? Now, I don't have a prompt here.
What is your strategy if your text is bigger than context?
So
Like, does it
what's
overlap?
going to happen is that if what you're passing in is larger than that context window, the default behavior is for the model to sort of truncate it. Or so you're not going to, you think you're embedding the entire thing, but you're not. And I've run into that. So your embeddings aren't as accurate as they otherwise sort of could be.
Okay.
And your model servers like an Olama, once you get over the context window too, it just starts.
So it'll basically chop off whatever text, and
my guess is it will just start cutting it out. And so you're only embedding what's within the scope of the context window. So you do need to be looking at your context windows and understanding if you're going over them or not. There is a way to use images to extend. There is, but I don't have an image situation here. Images don't fall within the context window. Then again, what we've been learning on the vision models is it really depends on how the vision model works. If they're working on RGB, they could very much be doing that. From a chunking strategy, that's a whole sort of another conversation that I think
they compress text into images.
Yeah, I'm not sure what model you're talking about or what context you're talking about that in, but we can have a side conversation if you send me an email. I don't know enough yet about that. But remember, not all embedding models are multimodal or support images. So,
yeah,
and that would have to be done by the model server anyway. And so if your model server, and we are the model server right now because we're using Llama CPP. So unless Llama CPP is doing that underneath, which I doubt, and the embedding model doesn't support images, which I don't think this one does at any level, I would imagine that you wouldn't be able to do sort of any of that. But they're interesting sort of ideas anyway, right? But right now what we're trying to do is do all this stuff within the scope of a single Go binary. That's what we're playing with. So we end up with a binary that we deploy that has everything you need in it. And we're well under the context window, I think.
I think so.
My only thing is, remember the prompt that we had, right? This is the prompt that I want. Hold on.
Use the following to answer. Yep.
So let's take that here. Let's do this. Then what we'll do is say, we can even just hard code this right now, dude. I don't sort of question. Well, we're going to have to take the context anyway. So here's the question, right? There's the prompt. Oh yeah, we're embedding the prompt here anyway. So.
Oh, because now.
Oh yeah, right now actually we don't need this because I'm not looking to get an answer back yet from the.
Okay.
I'm not ready to get an answer back yet from the thing, right?
You're just trying to see if it finds.
I just want to see what it finds as the top sort of 3 for this. So we're fine there. So let's go back to if this works, which would be cool. And how long it takes would be cool. And we get back answers, that will be cool. I'm not going to do any output right now, but let's do the following at least. Load the data. All right. Time.now. And then we'll do, he knows what I want to do. Yeah, time since. So print line, all right, loading data. Let's see how long that takes. I'm not going to print anything just yet. But there's, I think there's about 300. Oh, we're going to see this anyway. So, all right, let's just see what happens. I have zero clue what's about to happen here. So let's see. Whatever even works remotely.
Loading data. 3.
Boom!
Blew up.
No, we're not going to detach, whatever. Leave me alone. I want to detach. Stop. So that blew up.
That's llama blowing up, right?
Yeah, that's llama blowing up, bro. Like beautifully blowing up. Now, we got 1. We got 2. I think it blew up on 3.
I think it was 3. Yeah.
Right, and the third, maybe we're hitting context windows. The third chunk would have been,
No.
third chunk would have been this one. So that's interesting, right?
But that's nowhere near.
I mean, I don't think
Context
so,
windows.
but let's do the following, just so we are sure, right? So I'm taking each chunk and I'm removing the chunk. But what if we just did this? Just to see if we're blowing up at all, right? Let's do the length. Say you set the length of 1024, and if the length of the chunk is less than length, then we want length to equal that, in other words. You understand?
Mhm.
So we'll take, it has a min function. I always forget about the min function. Replace it. I always forget about this new min function. So essentially, we'll either take the length of the chunk or just the first 1024. Okay. Let's just see if that's it, or let's just see if we're pushing this too far. Okay, so we definitely had a length issue.
Yep.
That
is.
That's fine. Why did we get? Oh, it returned content. Okay, let's do the following.
Okay.
Let's change this. We think the context window is what, 8K?
8. Yeah.
Let's take this to 4K.
Testing the limits of llama right now.
Well, more of the. Okay, so 4K was like out of touch. We have to find out where this number is. 2048, right? Now, it could be our code blowing up too, because remember we had some weird buffer in here.
I mean, the buffer was that first number, the 1024.
Yeah.
On the embedding, or was it the embedding?
I don't remember where that came in.
I think it was embedding. It was in the SQL.
So maybe we got to do the following. If I go back to, maybe I can, when we do this, maybe, I don't know. Because there is no 1024 here or anything. So, because if I go back to the model, I hear everything that you're typing and you're right, but we are in hacking mode right now, just trying to get Llama CPP to run directly in Go without CGO to do embeddings and do all this stuff. The stuff you're talking about is important for optimization. So yes,
that's like more advanced.
We are very clear that you have done this before. We will get to all of that one day. Okay, so this might be something we have to do offline because we're at, I don't know what these numbers just mean yet, but we know 1024 was fine, right? but we also know that's sort of our embedding length. This is now about how much we can feed to the model, this text to the model when we're sort of doing the tokenizing, right? But that's based on count. So this might be a Ron question for next week as well. It's just maybe something I'm not seeing. But if I change the context, oh, I was like, did we actually get there? And the answer is no. So I don't think that did sort of anything. And so this is all we know right now, right? And maybe there's model params too that we can deal with here. Let's just take a look for a second. Yeah, I don't know enough. This is where we're going to need Ron to sort of help us here because I don't see anything there. All right. All we know right now is that if we, where is that code that I added so we didn't go over?
Did you already remove?
Oh, it's in here. All we know right
there it is.
now is that if we don't go over this number, like, right? We don't go over this number, we're good. We don't know where that number is coming from. We don't know enough about Llama CPP yet to deal with this. I was really hoping that that was the number, you know?
The only thing that's 1024 there is the embedding length.
Right, but that's what comes back, right?
Yeah,
We shouldn't
like-
be necessarily limited to that. Like, if I did, right, make it a little bit bigger. I just don't know what. Yeah, we've read the model card. The model card is saying one thing, but it could just be that I'm not setting something on the Llama CPP side, and I'll need
like it's a default value or something.
yeah, I'll
of
need to set it or
1024.
something. That's why I was trying to set that context. Right, we set it to like, that was my sort of idea there, but that didn't seem to work, right? That didn't seem to work. We tried it though. Now maybe the batch too or something, because he sets the batch in this example, and we don't know enough about that. So what if I did both for a minute? Set them both to that number,
Okay.
right? I'm assuming. Yeah, that's good. And I'll just add another 512. See. If not, we'll need Ron. Ron can tell us next week. No.
Ooh, I thought I got close.
No, I think it keeps blowing up on 5, which I wouldn't be shocked if on number 5 the length of the chunk is right, is big. Yeah, so look, we got a chunk of 1406.
Oh, okay. So it
And
was.
that's the one that's sort of blowing up. So, yeah, I don't know. So this isn't helping us, right? And that makes it interesting because if I do 400 here, oh, dude, that was 1146. Yeah, I don't know how to fix this problem. We're not going to be able to fix this problem anytime soon. So what we're going to do then is it's 1 o'clock. So what we're going to do is the following. We're going to just leave this code the way it is right now. On Tuesday, whoa, didn't we get through this at 1024?
Yeah, we did. But there was other values, right? That were Oh no, that's the one that
No, we got through this on 1024.
we.
Like, that's weird. So maybe it's something completely different. Wow. Yeah, I don't know then. Because what?
We definitely did though.
Yeah. So use either the min. Maybe this code got whacked. Oh, yeah. Chunk from beginning, whichever one is smaller, the length or the context limit. And I know we got through it. Now, maybe we're just using the APIs wrong too, or something, right? This is all sort of, I want to keep up and better prepared. Okay, so now I don't know what's going on because we got through all of this at some point, right? All right, well, we're out of time anyway. I want to know what the length of the chunk is that we're going to use. Yeah, okay. Whatever we did, we just went way backwards, right? Wow. Whatever we did, we just went way backwards. So
There was,
I don't know what happened.
but wasn't there some other changes that you made to the parameters?
Oh, let's get rid of them.
Yeah, there, those.
Let's get rid of these. You're right. Let's get rid of those and try this again. Yeah, that definitely caused some nastiness. Okay. So at 512, that works, but we're not going to get the whole thing. At 1024, it works. So,
Hear the noise
what noise?
whenever it's counting up. Is it coming from your Mac? Watch. Try it again.
I don't think there's any noise, bro.
100% there's a noise. Watch. Wait for it to stop.
Why would that be creating a whistling noise? Wow,
Done.
that's crazy. We could look one more time very quickly at the embedding example, but we did everything that he's done here. So I don't know what the pooling means at any level. And everything else we've done the same. So, okay. So I feel pretty good. The only other thing maybe, and again, I don't know what pooling type means. Where is the pooling type used in there? Type unspecified, none, type mean. I don't know what the pooling type means at all. We can ask.
It's a part of the architecture.
But I think it will just take it, maybe. Yeah, I don't think we need pooling either. One thing we could also just try real quick as we sort of, if I get rid of that, this should still work, right? Okay, so it's still working at 1024. Yeah, I don't know why that's
Dude,
weird,
it
isn't
definitely makes a noise though.
that's wild, dude.
I've never heard that.
Okay, let's save this. We're gonna have Ron on Tuesday, so maybe Ron can tell us what we're missing here. But I'm sure if I set this to 2048, it's gonna go ba-boom bees. Yeah. Okay. So at least right now we know that we can only have embedding of about 1024. But look, when it does run, right? This isn't taking that long to do the embedding. So that's not something, we can do something on application startup for this. It's only 365, right? But even with the 1024 embedding, right? I'm printing out all that shit. We shouldn't do that.
It took about 10 seconds. No, 9.
Yeah. Okay.
9.3.
Let's do one more thing before I save this code. We don't need to print everything, right? Remember how I was, we don't need this code. Let's get rid of it. That's what's causing me some pain too. Okay. And then we don't want to print the entire chunk when we do this. Where is it? I called it name. Oh yeah, the name is silly because the name is really is the data. Well, we can fix that. Let's just print the first 100 bytes.
Dude, that is the craziest thing.
Yeah, why would it do that?
I would love to know why it does that.
So how do you declare a variable and go? Even though we're only using the top 1024, right? That's cool. I don't know how good that is. But it's interesting, right? I mean, it's working at some level. We have to solve the 1024 problem. But assuming we can do that with Ron on Tuesday, which would be really good. I think we did really, really good today. We have, let's do this. Get commit minus, we have the beginnings of a self-contained sort of RAG app, right? So that's good. And my friend who joined and is going crazy with comments, yeah, the 1024 is what's coming back as part of the embedding. However, the amount of context that we should be able to add to the model, I think should be bigger, like this context length here. So I don't know how to get to that, but Ron Evans will know how to get to that. And I think we'll get that fixed. Worst case, we swap out this model, embedding model for another model.
He might know a better model too, whichever one he uses.
Yeah. So when we get Ron, let me switch over here for a second. When we get Ron on the show Tuesday, I'm going to show him what we're doing, how crazy we are. Get him to either suggest another model or fix this one so we can have a larger context window. But dude, we've got the DuckDB doing vector search. We're doing the embeddings inside the Go program using Llama. We're running into like silly little things. But Ron knows these APIs really well. So my guess is he'll get us over these little humps.
Yeah, for sure.
And then we can keep sort of plugging away at that because I think this is going to be very cool. We're close, right?
Yeah,
we're close. We just we have a couple walls, but all right, everybody.
Detail.
Join us on Tuesday. Got Ron Evans, who wrote the Zima package, who's given us access to Llama CPP from Go without CGO. He'll help us with this embedding to get these larger context windows. He'll see what we're doing and he'll be able to hack with us to sort of make all this happen. And I want to run some experiments while he's here too, to do the concurrency stuff. So how much concurrency can I throw at this? Do I have to keep loading individual models? Can I do it against the same model? There's a whole bunch of things I want to ask him. So, so we'll do that. So I appreciate everybody hanging out with us and we'll have a great weekend. We'll be back on Tuesday.